Hi, everyone. Welcome back. I'm Brett Norton from Beyond Clean, and it's been such an incredible day of learning. Thank you all for being engaged with all the discussions we are having today. It's been pretty awesome from starting up till now. We're 4 sessions in, and we still got more to go. As a reminder, in the upper right-hand corner of your screen, you'll find many downloadable documents that have been provided for you by our event sponsor and speakers. So please make sure to hop up there and pull off PowerPoints. I know that we will be highlighting a few downloadable resources in this upcoming discussion, so make sure to pull those off of there. Another just real quick reminder is if you're having any trouble with any audio or if the video freezes up or anything like that, you can always refresh your browser, so that just helps that come back and your feed should be fixed and ready to go. So just a quick tip on that end. And also wanted to just remind you that we have a couple of conferences upcoming. We have one right away next Friday on July 23rd. It's Be Sure, which is sterility and packaging and sterile processing in sponsorship with CCI and 3M. And we also have a number of virtual/live hybrid events coming. So keep your eye on that. So with that, it is my pleasure to reintroduce our next guest. If you didn't get a chance to hear our introduction earlier, Michael Matthews is the Director of Customer-Facing Training and Education at Agility. Mike is Lean Six Sigma Green Belt certified and one of the most down-to-earth, easy to listen educators that leaves you with specific actionable steps to improve your department and approach to instrument care. Every frontline user knows the stress of medical device breaking down on the day you need it most. In this session, Mike will identify common sources of preventable damage to medical devices and suggest best strategies for developing ongoing quality improvement programs to help prevent medical device damage and lower repair costs. Are you ready to discover how you can help reinvest in your department and ensure the safety of the devices your surgeons and patients depend on every day? Let's learn how we can protect our endoscopes with Mike Matthews.
All right. Thank you, Brett. It's my pleasure to be back again talking about this subject, auditing to prevent damage to medical devices. And I know auditing is probably one of those things that, nobody gets just super hyped for. It sounds kind of boring, and we're going to be talking about process improvement. But what I really want to accomplish today in this session is show you where in the process damage happens, and then how we turn that into actionable data that we can then turn into resources that our department desperately needs. So we're going to look at a couple of things, and yes, there is going to be some overlap. There's going to be pictures that you saw from the previous session that I did because the other session was sort of like a high-level overview of what are the general care and handling practices. Now we're going to look at the process itself so that we can see, okay, where in the process is this stuff happening? Now, the kind of the reason we created this material that we're going to be going over today is that we go to a lot of facilities, and I have not been to a facility yet that says we have too many devices, like we have too many flexible scopes. By far, the vast majority of instances that we run into, places and technicians feel that they do not have enough scopes, right? And so what this means then, and to get into that, what that actually means in a practical sense, I'm going to take my cue from the airline industry. And the airline industry has a lot of things that I really appreciate and really enjoy, and especially as somebody who flies a lot, they are safety related, so I very much approve of them. Because if we didn't believe that airlines were safe, we would not fly, right? So they have a lot of research into safety standards, and one of the standards that they use is what's called human performance metrics. And what they did was they looked at a wide range of people, and they said, okay, the average person how frequently will they make a mistake? Because a mistake in the airline industry, can lead to a plane crashing, right? So this is a big deal, and we're in the same boat in the healthcare industry, right? Because a mistake can lead to patient harm, and it can lead to expensive repairs. So this is a big deal for both of us. And so what the airline industry found was that an average person who understands a process very well will make a mistake about 1 per 100 opportunities. So 1 per 100 opportunities, the average flexible scope will have around 130 steps from beginning to end in a single process, a single reprocessing phase. So on average, if, even when we understand the process well, we're going to make probably 1 mistake per reprocess. And actually, I think there's a lot of technicians who might even be a little better than that. And that's awesome. Like, that's great. We need to, celebrate those things. But unfortunately, what we run into is this situation where technicians, they don't feel like they have enough scopes. So they get this pressure to hurry up, go faster. And that creates stress. Now, when you add stress to those same performance metrics, they get significantly worse, right? So instead of making on average 1 mistake per 100 opportunities, that number goes from 1 in 100 to 1 in 10. So 10 times more likely to make a mistake. And so in a 130-step process, that means we go from making 1 mistake to making upwards of 13 mistakes per reprocess. And that increases the likelihood that what that mistake is something that is catastrophic, whether that be damage to the device or that be damage or potential harm to that patient. And all of that is coming from the simple additive to the process of stress. So here's how the cycle works, and you get caught in this nightmare cycle. And this may sound familiar to you, that you don't have enough devices, right? You don't have enough devices, so you feel that you are under pressure to go faster, which means that you are more likely to make mistakes, which means that you are making more damage to your devices, which means your repair budget is out of control. You're spending too much money on repairs, which means, guess what? You can't buy new devices, right? And it just around and around and around it goes, because you're spending too much on repairs, which means you can't spend more money on capital equipment to get out of that loop. So how do you break out of this vicious cycle of equipment damage? And so to do that, we created these audit tools to help you understand where in the process your devices are actually getting broken. Okay, so our objectives today, we're going to explain the need for the auditing process. We're going to identify some common sources of preventable damage to flexible endoscopes. We'll talk about best practices for preventing damage to flexible endoscopes, and then we're going to talk about a strategy for developing an ongoing quality improvement program that prevents damages and lowers those repair costs. Okay, so why do we audit? Why would we do this? And I think you heard this a lot in the previous conversation between Hank and Frank, that data. This is about gathering actionable data. So ST79, for example, says that performance measures for problem investigation should include, among a lot of other things, but instrument and equipment damage or failure. So if you don't know how often or what the root causes of that damage happening are, and you're not auditing those processes, you kind of get in this I'm just putting out fires mentality, right? So I'm not in control of the process. I just know when something breaks and they call me, right? And you're just constantly getting run around from place to place to place, trying to put out fires, trying to solve problems, and you're not taking control of that process. If you don't have data, you don't have control of the process. And so this is about getting that data to take control. And then, like we talked about in the previous session, we said that the average cost for a flexible scope repair is around $2,000. Now, it can be lower, it can be a lot higher than that. That's just kind of an average benchmark. And the main point that I want you to take away from that is it's expensive. These are high dollar repairs. I said it last time, I'll say it again, that by far in facilities, the flexible scope repair budget is significantly higher than any other form of medical device in the OR or the endoscopy suite. And, like it's sometimes more than all the other modalities combined. So this is a huge amount of money that's tied up in these repair costs. And most of them are either you can mitigate them, lower them through improved processes. In some cases, you can get rid of them altogether. So, we can do this. The other piece is this is a proactive approach to quality assurance. If you do not have a proactive approach to quality assurance, what's happening in your endoscopy suite or what's happening in your OR is that the patient has become your testing media. Right? A testing media is the thing that we test a device on. And so if the patient is your testing media, that's a bad situation because no patient has signed up to be the testing media for the device. And if you let the OR or if you let the endoscopy suite tell you when something is broken, that means they tested it on a patient and it failed. So guess what? That patient has in some way been affected by that, even if all they did was just switch it out with another device. That slowed that down. That means there's more time under anesthesia for that patient. It probably increased the stress in the room. And guess what? All that stuff I talked about earlier where the cut says that as stress goes up, mistakes goes up, that's true for the OR staff as well. So as they're getting stressed out because their devices aren't reliable, they are more likely to make mistakes as well. So the key to this is it is our job. We are the gatekeepers of this device. We are the ones who determine whether or not it is safe to be used on that patient, not the OR who says, oh, we used this on a patient and it didn't work right. So proactive is the key to this. So we created what we call a damage prevention audit tool. This is free, available in your resources section. Please download this, make as many copies as you would like. Be sure, you can customize it, add stuff for your own. This is a general checklist. This is in no way meant to be comprehensive. You can add this to regular compliance audits that you're already doing, because this audit is primarily designed to identify where those preventable damage issues are happening. So again, free to download, go for it, make your downloads, take as many of these as you want. Inside this, you will see there are 4 audit checklists. There's one for flexible scopes, rigid scopes, power equipment, and video cameras. What I hope you do is as you see this audit process kind of take place, you will begin to see that, hey, I can apply this to a lot of other areas. So one time I did this presentation and I got a question that says, hey, can I apply this to my robotic scopes? And the answer is yes, you absolutely can. You can take what you're learning as far as the audit process, and you can take what you're learning about the process improvement process. You can sit down with the IFUs for a particular device that your facility is struggling with, and you can make your own audit checklist. So take this and customize it to fit your needs, and this will help you identify your process and where those problems are. Okay, so we're walking through the process now, and our audit checklist starts with the OR setup. You can start it in other places. I talked to one account that said that, we like this, but we want to start in prep and pack so that we can finish in decontam. Can we do that? Yes, you absolutely can. There's no reason you have to start here. We just seem to think that the best place to end is at storage. So which means that the next time you pick up is when it's picked out of storage to be used on a patient. But, that's where we start. That does not mean that you have to start. Now, what we want to see happening at that OR setup or in that endo suite setup is we want to see that there are inspections being done immediately before the patient is being brought into the room. The reason for this is that this is the last chance opportunity that we have to find damage before it actually affects the patient. And you can even look in multiple flexible endoscope IFUs, and they even have a kind of like a list of things that you can do to inspect these devices pre-procedure to ensure that they are ready to be used on that patient. So this is that last check opportunity. This is one of those areas where, you know, finding damage at this point probably won't save you any money, but it will save you the stress, and it will save that surgical site failure, or that procedure bedside failure, and increasing the stress. It will also help keep the doctors uninvolved in this, because you don't want the doctor being the one that tells you when something is broken. You want to be the one that finds it when it's broken, because when the doctor finds something that's broken, that's when it goes way above your level and they throw a fit, and now they're involving, you know, the president of the hospital and all that sort of stuff. Like, if you catch it here, only you and the repair company know about it, right? So you don't have to worry about that. So among the things that you can do, you can check that angulation system. You can look for the lamination on the insertion tube. So when it kind of changes from that nice, shiny, let me get my drawing tool out. So when it goes from this kind of really nice, shiny color to sort of this dull, matte color, you know that that insertion tube is beginning to wear down. Just through regular exposure to the high-level disinfection chemicals over time, that will wear out. And that's a kind of that early warning sign that lets you say, okay, it may function just fine right now, but I need to go ahead and get this out at some point in the very near future, because this is kind of like a ticking time bomb. Like, this is going to break at some point soon. And if I can do that proactively, that's much better than doing it reactively. Now, after we've observed our pre-procedure setup, we're going to observe the actual use of the scope in the procedure. And you're going to notice the functionality and how it's performing during the procedure, but you're also looking for improper use by the physician. And we know that physicians do cause a significant amount of damage, and it's very difficult sometimes to have that conversation. I definitely would not recommend having that conversation during the procedure. That's a very, very bad idea. If you're observing and you see the physician kind of holding the scope like this, like we talked about in the previous session, don't have that conversation there in the room. Say, hey, doc, you're doing that wrong. That's a bad time. What the audit process does is it allows you to make the observation, make the note, gather this to where you see it as a repeatable offense, a repeatable thing that's happening. And then as you gather this information, you can pass that information to an administrator and say, hey, we did some audits. We did 10 audits, and at 9 of them, the physician was doing this particular practice that leads to additional damage. Can you have this conversation with the physician? And I've talked to a lot of facilities that say, like, no, they're never going to do anything to the doctor. The doctor gets free reign to do whatever he wants, including damage. And even if that's the case, and most of the time I think that's an exaggeration, but even if that is the case, like, I accept that that's the case, let's assume that it is, this gives you your ammunition to at least push back. So when the administrator comes to you and says, hey, what's all this damage? You need to quit breaking stuff. You can say, hey, we did these audits and we've done our part, but this is still happening regularly. If you want this number to come down, this is what needs to change right here. And you've already got that documented in an objective format. So very good to kind of make those notes and then have those able to be reported off. Okay, so we've observed the procedure. Now we're moving into the pre-cleaning phase, and this is kind of, pre-cleaning will be specified for you in the IFUs. There are some generalities that it has to be done immediately after the procedure. If you're doing a double procedure, like an upper and a lower, where 2 scopes are in use, that first scope still needs to be pre-cleaned as soon as it's done being used, because if it's not, it's going to end up sitting there on the side, waiting for the physician to be done with the next procedure, which could take over an hour. And during that whole time, mucus, bioburden, blood, stool, whatever is just inside these channels, just hardening and getting more and more difficult to clean. So it has to be initiated immediately after the procedure. You're definitely going to want to wipe down that exterior with a lint-free cloth or sponge. And of course, aspirating the water using the high pressure button if this is an Olympus scope. But whatever that aspiration of the cleaning media is, at the pre-cleaning part of the IFU will specify what that specifically is. And then when you get into more complex scopes, especially those that have elevators like the duodenoscope, that will have a separate section too that dealing with that elevator. So you have to know what the specific scope's pre-cleaning steps are, or you're going to see a lot of additional damage and patient risk from things like clogged air water nozzles. This is the angulation section about the locks that we talked about previously, that these locks, if the physician uses them, you want to disengage those as soon as you get done with the procedure, because any movement at that angulation system or in that distal tip during the reprocessing phase, when those locks are engaged, is going to significantly stretch out the angulation system faster. The same is true for the tensioner as well. This is my Drake beam. I'm very proud of my Drake beam. I've showed it to a few people. One of them even laughed. That was cool. I was very excited. This is I'm very proud of this. This is that transportation piece that we talked about in the previous session too, that when we see this kind of transportation, we're going to see lots of additional damage because there is no support for that scope. It is collapsing down on itself. It's getting kinked up, and there's nothing that you can do to stop that kind of damage. This is by far the preferred form. I even like this particular picture right here because look at what this facility did. There's no standard that tells you have to do this. That's not a very good drawing. Let's do that. There's no standard that says you have to do this. But what they have done is they have taken their pre-cleaning sponge, and they have, after they wipe that distal tip down, they left that sponge on the distal tip. And the reason for that is that it just gives that distal tip, where that really expensive CCD camera, gives it a little extra cushioning so that it ever gets bumped into or banged against something, it's a little bit more protected than it was. And then you transport it to decontam with that, and then decontam, they throw the sponge away, right? So it's just a little extra cushion, a little extra protection for that distal tip where all the money is. And I think that's a pretty clever and neat idea. Leak testing, we've talked about it multiple times already. It has to be done every single scope. Fluid invasion is extremely detrimental to these. One thing I definitely want to recommend, though, is that in addition to doing your regular leak testing, you need to test your tester. What are you doing to ensure that your leak tester is actually pushing through the correct amount of air to ensure that it's actually doing what it's supposed to be doing? Now, this becomes a very significant issue if you're using probably the most common leak tester that's on the market, which is the continuous airflow leak tester, where you plug it in and it just kind of pushes air through, and it's up to you to visually identify when a leak is happening when you do the leak test. Now, if that leak tester is not pushing air through, guess what you're not going to find? Leaks. You need to check that the hoses, to make sure they're attached properly, that there's no holes in them, that they actually are pushing air like they're supposed to. You'd probably be very surprised at the number of times we go to a facility and the facility says, hey, we keep getting fluid invasion in our scopes, but we leak test them, so we don't know where it's coming from. And you go to their leak tester and you kind of push the button and stick your finger on the hose, and sure enough, no air's coming out. So no air means no leak, right? So it's not telling you anything. So know what your leak tester needs to be able to do its job properly and ensure that it is functioning also. All right, we already talked about the damage to what we call the C cover, or the cap that sits on top of the flexible endoscope. But again, you've got to have that lighted magnification to be able to see all of the things that could potentially be going on there, including all those scratches like you see on this one on the screen. And you have to actually be using the tool for it to actually work, right? So inspect that distal tip during your cleaning process. We want to see enzymatic being dispensed into the sink water according to the IFU. I think I've told the story many times that when I first became a technician, my training on enzymatics was, this is the stuff that gets the instruments clean. And so in my, very young technician mind, I was thinking, well, I want to get my instruments really, really clean. So I'm just going to use a bunch, like a whole bunch. I was using like half a bottle in one sink or something, because the idea is like if it gets it clean, why wouldn't you want to use as much as possible, right? But enzymatic, not a good idea. Not only is that a waste of money, but enzymatic also gets very difficult to clean off, to rinse off once once you have too much, it gets too concentrated. So it's very sticky. It makes it hard to rinse off. It leaves these residues behind. Let's give you a pro tip right now. If you go into your department and you look at your scopes, and if you see any scopes where the numbers on the insertion tube are kind of changing to like a yellow or a brownish color, that means there's enzymatic residue that is getting stuck onto your scopes regularly. And in addition to, just the fact that it's sticky and hard to rinse off, that means that that's areas where the high-level disinfectant may not be able to make direct contact with the scope itself, because there's this layer of enzymatic residue that's stuck on there. So that high-level disinfectant hits that enzymatic and it just stops there. It doesn't make it through to the actual scope. And so it does create this inhibition. It inhibits that activity of the high-level disinfectant if we aren't dispensing correctly. And then we also want to see that the scope is being handled delicately through the whole manual cleaning process, or not dropping it into the sink, not hitting against the sink side, no kinking. And I know, especially if you're really experienced at this, you're probably sitting here like, duh. Like I did not need an in-service to tell me not to drop the scope into the sink. Like, I got it, right? But what we find is that as that pressure is pushing on the technician to hurry up, that technician starts moving very quickly. And as they're moving very quickly, they're thinking about what's the next step, while not being mindful about what's the step I'm on right now. And that's when you see scopes getting banged against the side of the sink, because they're in a hurry to pick them up and put them into the AER, or they're in a hurry to take them out of the transport tray and put them into the sink, or whatever, And this is the real value of having that third-party person step in, assist the auditing process, because they're the ones who are going to watch that and see that. And that's when they need to start asking the questions of, why are they in such a hurry? Why are they rushing so much? Because they're making mistakes that they're not conscious of. I'm a firm believer that the vast majority of these care and handling mistakes, nobody's doing any of this on purpose. Like, nobody's intentionally setting out to break these devices. And it happens, but it happens a lot. So if nobody's doing it on purpose, how does it happen? Because we're not mindful of the process. We're making mistakes that we're not aware of because we're just in too much of a hurry. Making sure that the scope is being handled correctly as we move it from the sink into the AER. Again, making sure our big, heavy light guide connector doesn't get set on top of our super small and delicate distal tip when we load it into the AER, because if we set it on top of there, it's going to do a lot of damage. All right. If we're doing sterilization, obviously we got to make sure that the pressure cap is on, and that if we are using a rigid container for sterilization, which you probably are, that it is actually designed for a flexible scope. I have seen many instances where a small diameter flexible scope was crammed into a way too small rigid container, like the kind you might use for a video camera, and they just kind of bend it up to make it fit in there, right? And then are shocked when their devices come back damaged. It has to be designed and fit specifically for flexible scopes so that it doesn't coil them up too tightly, or else you're going to end up with lots of extra damage. And then, of course, making sure that the scope can be transported from that AER to the storage while holding the scope with two hands. And we want to make sure that that scope is being hung in its most free position. When you see scopes kind of doing this little measure right here, where they kind of do a little bit of that, we call that snaking. That means your angulation system is getting stretched out. Those wires are pushing out against the side of the insertion tube. And when you hang a scope freely and that pressure's being pushed out, that's what it looks like, that little snaking action. And even when you see some curvature like this, that can be an indication of a problem with your tensioner system or your angulation system as well. So, just by making those simple observations, can help you understand where that damage is coming from. And again, I think storage is probably the second most common area that we see a lot of preventable damage happening. And it is because of one of my favorite facts, that this light guide connector is the equivalent in weight to an orthopedic mallet. Now, let's think real hard about it for a second. If I were to go to your facility with an orthopedic mallet and start swinging that mallet around inside your scope storage cabinets, would you be happy with me? Would you even wonder where damage was coming from? Like, we don't know where damage is coming from. I mean, it might be this guy over here who runs around with an orthopedic mallet and swings it into all of our scopes. I'm not sure. But guess what? Every time we are in a hurry and we put a scope into the storage cabinet, or we take a scope out from the storage cabinet, and all those other scopes are swinging around and banging into each other, that's the exact same thing. That orthopedic mallet is swinging around. And guess what? Especially on like colonoscopes, that light guide connector hangs at almost the exact same height as that distal tip where the CCD camera is, right? Who wins between the orthopedic mallet and the $6,000 camera that's the size of a grain of rice? Ta-da! The orthopedic mallet every time, right? So we have to make sure that we've got the right storage, there's enough space, and that we're not cramming a whole bunch of scopes into a storage cabinet that is way too small. And this is where it really comes down to, right? And I alluded to this in the previous presentation, that we want to camp out on this issue of, are there an adequate number of scopes for the number of procedures that are being performed? Because this is where the stress really comes. And Ofsted and Associates, in association with Isham, did a survey that said that 70% of reprocessing technicians feel that they are under pressure to go faster when reprocessing scopes. That is stress. That's that 10 times higher risk for mistakes, that 10 times higher, more frequent mistakes. And guess what? The scopes that we're most likely to be rushing on are the scopes that are the most expensive. That's why you don't have enough of them. So it's things like your EBIS, your EUS scopes, the ones that cost $70,000, $80,000 a piece. You've only got 2 of them in your whole facility because they cost so much. They're the ones you're hurrying up and reprocessing the fastest, and they're the ones you're making the most mistakes on because you're under pressure. So sometimes not having enough scopes is actually leading to more cost than what having the proper number of scopes would require in the first place. So it's really easy to say, just buy more scopes, right? Because every facility has an unlimited budget and can just do that, right? No, you're trapped in the loop where you can't buy new scopes because you're trapped in spending too much money on repairs because you're under stress and making too many mistakes. How do we get out of the loop, and where do we find money to buy more devices so that we don't feel under pressure all the time? All right, so we're going to look at a process improvement model, and we're going to put some dollar figures on it. And I'm going to introduce you to a very simplified version of what's called Lean Six Sigma. It's just a very simplified way of looking at a logical pathway through determining what a problem is and focusing our efforts on that, fixing that particular problem. And you may not have ever heard of Lean Six Sigma, but you have probably been affected by it. If I were to tell you that I just bought a brand new Toyota, you would probably respond by saying, hey, that's a pretty good car. I bet it's going to last you a really long time. Why would you say that? Because Toyotas have a great reputation for lasting a very long time. How did they get there? Well, guess what? They've been using this system for decades. It's part of their culture now. And they see this a lot in manufacturing, where you're dealing with processes that result in millions of products, right? How do you ensure that all out of your million products, that every single one is a consistent, reliable product? Well, you have to do things like this. And thankfully, this process, which has proven itself repeatedly in manufacturing, is starting to make its way into healthcare. So how do we take those types of lessons that can be learned in that process and apply them to our healthcare facility. That's what we're going to work through now. So we're going to work through the DMAIC system. That's DMAIC. Each one of those stands for a step in the process. And I'm just going to give you a little pro tip here. If you, as you're working through this process, if you create just a single like PowerPoint slide for each one of these and say, here's what we did at each step, that is an amazing presentation that your administrators will eat out of your hand, because this is how they think. Like I cannot, I can re-emphasize, and I can't say it enough. Listen to the previous session when Frank said that he had to think about this as an engineer and as a business person. This is what that process looks like, and that's what resonates with administrators, because this is what they do, right? And you're going to learn how to speak their language if you learn this. So what does D stand for? D stands for define. We are going to define our problem. Our problem is we don't know how much we're spending, and so we're going to find out, and we're going to find out how bad this is. So you can start that by talking to your repair company, whoever it is, and ask them, how much did you spend on flexible scope repairs, last year or last 6 months? Your repair company, regardless of who it is, should easily be able to give you that information. If they can't, you probably need a new repair company. But most of them will easily be able to give you that. All right, so next you're going to determine how many procedures are using flexible scopes in an average day or week, and then that's going to help you determine how many audits you need to get a good representative sample. Now, most of the time, people ask, like, what's the lowest number I can get by with, right? Because that's the wrong attitude, I'm telling you right now, because the more audits you do, the better your information will be. So get a good sampling size so that you can get a good feel for what's going on in your location. So this is what this may look like. Last year, let's just say hypothetically, we spent $100,000 on flexible scope repairs. And this is just made up numbers because I'm exceptionally bad at math. And I had to get my wife to help me on this. She's a former geometry teacher, so she does the math for me, so I only operate with very easy numbers. But in flexible scopes, we'll say that 20% on average is what we call regular care and maintenance. So this is kind of like on your car, how you have oil changes, right? Like you understand that regardless of the quality of the car, by the fact that you drive the car, there's certain things you're going to have to do, like change the oil regularly. So your flexible scopes are the exact same way. There are things you're going to have to do in order to maintain that. And that's about 20% of the cost. No matter what you do, that's not going away. But that means that of that $100,000, $80,000 of it is savings opportunity. So a good definition statement would look like this. Last year, our facility spent $100,000 on flexible scope repairs. As much as 80% of that is considered preventable. Therefore, this project will seek to identify sources of preventable damage and then reduce that overall spend on flexible scope repairs. Okay, that's D, that's define. Now we move into the measure phase. And the measure phase is what you're going to use that audit tool for. You're going to perform your audits. You're going to want to do a lot of them. More audits means more accurate information. So for example, if you audit 10 procedures and 3 of them have some type of failure, you've got a 30% defect rate. Now, don't be shocked if you do 10 audits and you find out all 10 have some form of failure. That's okay. The main thing is we're just trying to figure out how many failures do we have and where specifically are those failures happening. Don't get discouraged here. We're just getting started. So we're measuring. Okay. Next, we move into the analyze phase, which means we're going to look at our audits and we're going to look for areas that we can improve. And there's a lot of different ways that you can look at this, but the main thing is that we want to have targeted solutions. It's one of my pet peeves when a facility contacts me and says, we have a whole lot of damage to our devices. I need you to just come in and give them some education. I mean, education on what? The general in-service education doesn't really work. It's great for getting like a baseline understanding. It's great for building your competencies. It's great for refreshers. But when it comes to fixing specific problems, if you aren't targeting specific issues, you are never going to make any headway. All right. And one of my favorite sayings in process improvement is, if everything is a priority, then nothing is actually a priority. You cannot focus on everything. So if we're going to pick what we're focusing on, what do we need to pick? We need to look for areas of the most frequent failure. We're looking for areas that are expensive. We're looking for the areas that we can get the most headway in very quickly. So those easy wins. Maybe your department culture isn't real sold on process improvement. So how do you get their side? Well, maybe you just find a couple of things that are just real quick, easy wins. Once that gets that ball rolling, that allows them to see, oh, this isn't so bad. Oh, this is actually making my life better. I shouldn't fight this. I should adopt it. So it's okay to take sometimes some of those really easy things, just make those quick changes. Maybe it's just getting like a new product in or something like that, that enables them to see the vision of, okay, I can see the improvements. I can see where we're going with this. This is an actual audit that we performed for a customer. And I know the wording down here is really small. Don't worry about that. Basically, everything down here is just what we went through on the audit form, right? These are all the various opportunities that we checked. And what's interesting about this is everything on here is stuff that's sterile processing controlled. And this is the frequency of failure on this axis here, right? So we're seeing this here. Okay, so every time we had been called out to say, hey, come give some generalized education to sterile processing because our devices are getting damaged and, they just need education. Guess what? It didn't make any difference because they didn't need it. Their process were actually working really, really well. Over here, this is the stuff that the OR could have been doing. There's mistakes, there are, but it's not that much. You know what we found? There's this other group that nobody had ever talked to called transportation. And so in all the finger pointing, everybody had forgotten that there's this completely separate group that nobody had ever talked to, no one had ever given education to, nobody had ever asked their opinions about what their struggles were or how easy it was to comply. And what we found was all we had to do was talk to them, work with them to find some improvements, give them some education, and this big number right here started to go away. All because we actually knew where to focus our efforts. And that is the critical piece to this. So as we move in then to the I phase, which stands for improve, improve could look like a lot of different things. This is where you get to be creative. This is where you get to collaborate and talk to other people and involve stakeholders and ask them what they think, ask what their struggle is, ask them why they feel rushed, ask them why they aren't being compliant with this practice or that practice. Involve them and find out. It could just be basic education. Someone may not understand why the leak testing matters. They might not understand that their job matters and that what they are doing protects people. They think it's just something that OR yells at, right? So education can be a critical piece to this. Education delivered to specific groups, like the transportation group that we talked about. But maybe it's just one group. Maybe it's just third shift. Maybe it's the weekend shift. Maybe it's just this one group of new hires. You've got to really look at that and tailor the solution to fit where the data is telling you the problem is occurring. And, sometimes we have to invest in new products or new infrastructure, but this will help you make that argument. And a big piece to this is, test your solutions. Not every solution is a good solution. Not every solution is a practical solution. You may say, okay, we just add this to the process and you start using it and figure out, oh, that's terrible. That product doesn't work at all. Or it creates this other problem that we have to now deal with. So test those solutions and then re-audit to measure your progress. And then finally, we get to the control phase. And the control phase is what I like to say that it's the culture phase, right? Because you can make process improvements all day long, but if you don't change the culture, the culture will win. Everything will be undone. The process improvements, the things that you do, have to become part of the normal way your department functions. And by the way, this is actually the most time-consuming part. It takes time to change the culture of your department. And so there's a lot of little things that need to go into this. Obviously, we got to update our policies and procedures. The more buy-in we have from stakeholders, the more likely we will be to be successful. And of course, training new staff so that the new ones coming on understand that this is the way we do things, and having that attitude of, hey, when we have new information that tells us a better way of doing things, we're going to do it that way, right? Because we are in a system where we change our practice based on what is best. And, that's a cultural issue, and it takes time to do that. So roll those things out slowly, but be very intentional and be just doggedly persistent with changing, with enforcing those changes, because if you are not, the culture won't change, and ultimately nothing will long-term last. And then the big key here when it comes to these devices is communicate those successes to the administrators, right? Let them know you're doing this process. Let them see the improvements that you made. Put all 5 of these DMAIC steps into a PowerPoint slide and ask them for 10 minutes just to walk through what you've done in your department. And I promise you, they will be excited about it, and they will be very grateful. And it's going to help raise their opinion of your department across, the entire administrative staff. Okay, so what does that look like in practical terms? Let's say that you do your audits, you find that you've got a 50% failure rate. You've identified what the issues are, you've made some improvements, and now you re-audit and you've got a 30% failure rate. And a lot of people would stop there very discouraged and say, we did all that work, we went through that whole process, and all we did was make 20 percentage points of difference. Well, what does that actually mean? Well, if your 50% failure rate was an $80,000 preventable cost, 30% failure rate is a $48,000 preventable cost. That's $32,000 worth of improvement. Big, big difference. So let's have a poll real quick. Active poll. If your department had $32,000 available right now, what would you buy with it? Would you like to get 5 small diameter flexible scopes? Would you like to get 2 large diameter flexible scopes? Would you like 21 rigid laparoscopes, 13 power tools, 10 video cameras? Or would you like to get 5,342 Little Caesars hot and ready pizzas for the world's most banging pizza party? I'm going to give y'all a few minutes to answer this, give it just a little bit. And while I talk about this, it doesn't have to be these things. You think about, floor mats for your technicians. What about, borescopes at your table? Where you've heard borescopes talked about a lot. We know they're expensive. They're hard to implement sometimes. But if you can find the money to be able to get them, that's going to help you a lot. So do you need borescopes at each of your workstations? Maybe, if your expend is a lot higher, maybe that savings could turn into another full-time employee or a part-time employee. What are those departmental improvements that you need money to actually make happen? And you can take this money and then reinvest it back into your department for meaningful change. So let's give just another 5 seconds. Go get your answers in. Get them in, get them in, get them in. What have we got? All right. No surprise, endoscopy staff, they said we'd rather have the flexible scopes. 32% of people said we'd rather have the large diameter, 21 small diameter, and then we get some 10% say the 21 laparoscopes, 7% say power tools, 8% say video cameras, and I am shocked at you 19% of people who said, I want 5,000 Little Caesars pizzas. Now, hang on. Aren't y'all the same ones that get upset when administration just gives you a pizza party? Hang on. Now you're telling me if you had $32,000, you want 5,000 pizzas? Okay. Well, I bet that if you do this, you can probably get your large diameter flexible scopes and a pizza party. You just won't get 5,000, and that'll be okay, right? So the main thing about this is I want you to see that little incremental improvements, when they're focused in the right areas, will have tangible, actionable returns on investments. And those returns on investment can then be reinvested into your department to help break that cycle of not having enough money, to not have enough devices because you're spending it all on repairs and you get caught in that. How do you break that? This is how you can break that. You find the money by improving your processes and then reinvesting it back into your department and into your people. So with that, I'd like to say thank you to everyone for your attention, and I'm going to kick it over to Brett, I believe, for some Q&A.
Yeah, thanks, Mike. Also appreciate you bringing up some of the details on pre-cleaning. So I've got a couple questions on that front, but I'll go to the Q&As just so we can make sure that our audience can have their questions answered first. And this one is interesting because I think it has a lot to do with the number of surgical cases that are done at a facility, the size of the facility. And so, it could be a general answer, but this question is, how many endoscopes is adequate in any facility on average?
It depends on your process. And I know that's a great non-answer, but the reality is that your process is different than the hospital down the street from me's process, right? Because they're different departments. They have different issues, like the distance that has to be traveled between the OR and the reprocessing area. That makes a difference to how long your process takes. So if you go back to Frank's presentation in the previous session, they set it at 2 hours. Why did they set it at 2 hours? Because that's what the data told them. Yes, some go faster, but that's what they set their cap at. So what you would do is you would look at your process and say, okay, how long does it take to adequately reprocess a single scope without feeling like I'm pushed to skip steps, without that feeling of pressure and being rushed? What does that time frame look like? And you set that number and say, okay, if I'm doing, X number of procedures and it takes me Y amount to reprocess, X scope, how many scopes does it take to meet that demand? And so that's going to depend on you. It's going to depend on your staff. It's going to depend on your processes. But the key is, I cannot give you an accurate number because I don't have the data from your facility. You have the data from your facility. And if you don't have the data from your facility, you've got to go find it so that you can create the process that works for your facility.
Great answer. Thanks, Mike. Next question is, what are your thoughts on single-use endoscopes and endoscopes with disposable components?
Yeah, we're seeing this more and more, and, it does certainly simplify the process a bit because there's a huge amount of this audit that doesn't have to be done because you're just throwing one scope away and opening the next one. But one thing that you will find is that, per procedure cost goes up pretty significantly. And of course, I don't have any hard and fast numbers that to give you on that. But the reality is that, reprocessing scopes is a less expensive method, even when you've got a lot of repairs. And of course, the reprocessing, it really puts the ball in your court to find out how to do that more efficiently and less expensively. Whereas the disposable scopes, they kind of just take the process away altogether. And again, that's going to be something that your facility is going to have to determine is, can we manage this process efficiently? And if we can, then reprocessing is a more cost-effective solution. If you cannot manage that process, maybe you should look at disposables.
Awesome. Next question. how does SPD confirm or audit, so to speak, the proper and complete cleaning or bedside cleaning is happening?
Mm-hmm. Yeah, this is you're going to have somebody who is actively following a scope around. That's what the audit process looks like, and so that person will be present for the pre-procedure setup. That person will be present during the procedure. That person will be present in decontamination. They're following that scope. Excuse me. Again, I said it in the previous session. I'll say it again. This is a great partnership opportunity with your infection preventionists because they should be there helping you audit this process, right? They can help you identify other areas that may be of concern that aren't part of our audit, but are still very important to be looked at, right? So finding people, training them to be able to be auditors so that they can do this regularly is really the key, because you need to be following that scope through every step. Same scope through the whole step, start over and do it again.
Yeah, and I think, one of the things when I was in the hospitals is that when the Joint Commission was doing their surveys, a lot of their focus was on pre-cleaning. Mm-hmm. When is this happening? Are you doing this, for one? And what are your procedures and steps, for the process? And so I think, to your point on pre-cleaning, it's one of the most important steps, prior to getting, into HLD and everything like that. But it is a very critical step and something that really needs a lot of focus going forward.
Yeah, and just think about it. Like if you are doing these audits regularly and a Joint Commission inspector comes in and says, what are you doing for pre-cleaning? Like, what are you doing to ensure compliance? Like, how good that looks to be able to hand them, your audits and your results and say, here's what we found the last time we did audits. Here's our compliance rate. Here's where we want it to be. Here's the changes we made. Like, when they see that, even when they see, there's a couple of failures in there, but they know that you are actively monitoring that process. You are actively making improvements to ensure compliance and that you're watching it regularly. That's what they're looking for.
Yep. And then right away, they just move on, check the box.
Yep. Say you're doing it right.
Yep. Great. Next question here is, what advice would you give a technician who wants to implement an audit system but needs to convince their supervisor manager?
Mm-hmm. Yeah, this is one of those things that really needs to be done from the top down. And honestly, they may be looking at this and saying, like, hey, this is cool, but if it's up to me to do it, I just don't have time. Like, who's going to manage this process? And that might be their resistance, is like, you're just giving me more work to do. I'm already overwhelmed. So what if instead you went to them and said, hey, I've got the tool, I've got this idea for, saving the department money, let me do the work. What if I volunteer? Like, if you'll just give me a day to partner with infection prevention, talk through this, do our audits for a day, and just report our results. I think that most leaders would probably be okay with that. I think most of their resistance probably comes from the fact that they feel like you're probably asking them to take it on. And it doesn't have to be that way. Now, when it comes to making improvements and establishing the culture, you've got to have their buy-in. If you don't have buy-in from the leadership, chances are the process improvement is not going to stick. So getting their buy-in is critical, and part of that is just helping them understand that the work doesn't entirely depend on them. If you're just asking them to play their role in it, and then kind of showing them what could be possible. And so even just that number, just saying, what did we spend on our repairs last year? $100,000. Wow, did you know that we could save $80,000 if we get this figured out? Even if we just save 20, if we save $20,000, what are you going to do? Could you do something cool with $20,000 in your department? The answer is absolutely yes, I could.
Absolutely. Yeah. And I think, it goes across all spectrums too, that it's a team process. It's not just one person that is responsible for this. And I think, to your point, when there's a buy-in across the entire, team, it's much easier to implement. So, yeah, great answer.
I think it's one thing you'll find is that in the facilities where they are very successful in this, in process improvement, and when they're getting the resources they need and making those kinds of changes, that's usually the big difference maker. Is they've got buy-in from multiple departments. Like, it's not just on the manager to just bullhead everything through, right? They've got buy-in from infection prevention. They've got support from infection prevention. They've got buy-in from risk management. They've got buy-in from lots of places that equip them to be able to push those through. So it's not on one person.
Yep, exactly. Well, I guess that's about all the time we have. So, Mike, thanks again for your expertise, and really appreciate all your answers to the questions. As far as any of those that we didn't get to, Mike will gladly respond to them via email, and feel free to reach out to him directly if you have any additional questions. And once again, thanks, Mike. Couldn't be doing this one without you. So we really appreciate you coming on. And I think we've got about 15 minutes to the next session. So it's about lunchtime for a lot of people. Hopefully you can grab a quick bite and hop back on with us shortly. Thanks, everybody.